Okay, evaluate the dt convolution. Okay, let n equals to k in xn. So that's going to give you xk. And let n equals to n minus k in hn. So that's going to give you n minus k. So we're going to plot each one of them and then multiply them. So let's plot xk. xk 0, minus 1, minus 2. 1, 2, 3, 4, 5, 6, 7, 8. Now let's plot xn minus k. It will be much easier if you plot hk first. So plotting xk is very easy. You just replace the n with k and just go the step function, use un minus 8. That's going to give you the same. It's going to be same as uk minus uk minus 8. And that's going to give you this, right? Step function starts when k equal to 0 and then it ends at k equal to 7. Then x of k, just replacing n equals to k here. Okay, so wherever there's n is going to be k. So we're going to plot this first. So the amplitude is 1/4. Okay, next we will plot h minus k. H minus k will be the inversion of hk. Just flip the signal about the vertical axis around here. So all this 0 will be there, and then 1 becomes minus 1, minus 2 becomes minus 2, and all this becomes negative when you flip it. So signal is going to be going the other way. Zero, minus 1, minus 2, minus 3, and minus 4, and it's going to be 0. So this is h minus k. So next you can plot hn minus k. hn minus k or h minus k plus n, they are the same. So what you're going to do is just going to be adding n to all, plus n plus n plus n plus n. N is like a constant number. After flipping it, but we don't know what n is right now, just imagine for now n equals to 1 or 2, or just imagine it's 1. If that's 1, then 0, this point is going to be 1, and this is going to be 0, and this is going to be minus 1, minus 2, and minus 3. So n is just a number. It's just a parameter. Okay, that is h n minus k. So next what we're going to do next is we're going to multiply xk. We're going to multiply xk by h minus k plus n. So in this case, this is going to be n minus 1, n minus 2, n minus 3, n minus 4. So next we're going to slide this over to complete the convolution. So if you can see, if you slide this across x, and you can see at some point h minus k plus 1 and xk signal overlaps right here. When n equal to 0, signals overlap. When n equals less than 0, there's no overlap of signals. For n equals to less than 0, therefore for n less than 0, there is no overlap. And therefore the output is 0. Okay, now you start the overlap then. So you will begin to overlap then. Overlap when n is equal to 0, when n equals to 1, and n equals to 2, when n equals to 3, when n equals to 4. When n equals to 4, that's a complete overlap of xk and h minus k, n minus k. So when there's a complete overlap, when n is greater or equal to 0 and but less than 4, correct? K is going to be, the lower limit for k is 0, greater or equal to 0. The upper limit of k is controlled by n. So this is the lower limit k. The lower limit is 0, and the upper limit is controlled by this n, the value of this n. So therefore yn is going to be 1/4 the amplitude of h n minus k multiplied by the amplitude of xk, the summation of xk h n minus k. So the output is going to be the amplitude of xk multiplied by the amplitude of h n minus k, and the summation of xk multiplied by h n minus k when k goes from 0 to n. Calculate that, upper limit of k minus lower limit, and then plus 1 for range of n. So that's going to give you yn is 1/4 n plus 1 Okay, next, if we continue to slide, then n has to go beyond 4. n has to be greater or equals to 4. Sorry, n has to be greater than or equals to 5. N equals to 5, n equals to 6, and n equals to 7. After that, there's no signal, so you just stop here. So n has to be greater than or equals to 5, but then n must be less than what? N must be less than 7. And the next one is when n goes beyond 5, but it has to be less than 7, and therefore the k is going to be maximum value k can have as non-zero signal is 7. The minimum value of k is controlled by n minus 4. Therefore yn is equals to 1/4 summation of k is equals to n minus 4 to 7. So that's going to be 1/4 upper limit minus lower limit plus 1. N minus 7, so it's going to be 12 minus n. Now we have to continue to move n beyond 7. It's going to continue to move beyond 7. N is going to be 8, n is equal to be 9, 10, 11. When n is at 11, there's one overlap right here. So the range of n now is the n is going to be, it has to go equals to or greater than 8, but it has to be less than 11, less than or equals to 11. The last signals that are overlapping, at that time k is 7 maximum value. The least value k can have is n minus 4. K is less than 7 but greater than n minus 4. So yn is 1/4 upper limit, lower limit, upper limit xk hn minus k. So to evaluate this, upper limit minus lower limit plus 1. Now the k, the end range is different than before. N is less than 11, greater than 8. Yn is 1/4. 12 minus n, but the range of n is between 8 and 11. So if you continue to slide n beyond 11, the n goes beyond 11. If n goes beyond 11, there's no more overlap, you see. Okay. N goes beyond 11, there's no more overlap. Therefore, for n greater than or equals to 11, there is no overlap. So therefore Yn is going to be 0. Okay, thank you for watching.